Hey, Tom.
Dave, how you doing?
Good. How are you?
Doing just fine.
Is this your last talk, probably?
Yeah, this is my last presentation, and then I'm emceeing the demo jam.
Oh, okay. Awesome.
Almost done, and I'm reckless, Dave. I just did a system update and switched everything over. So I've given all my presentations on Mac. I switched everything over to Linux because I've got a little demo on this one.
Oh, wow. So it's not really battle tested yet, or
Well, the demo, yeah, I just validated it before,
okay.
which freaked me out, right? Because I ran the demo that I've got. It's a crazy short demo and it failed. And I'm going, you gotta be kidding me. I did this last night, but I fixed it. But yeah, boy, I'm glad I checked it again.
Yeah, it's fun. I've seen a lot of presenters are using other operating systems and other browsers and running into glitches. So can't hurt
Yeah,
to test it.
yeah, yeah. Make sure your stuff works. It's too dangerous.
Awesome. For those joining, this is a deep dive into Tiamat. This is why you should be using it, and we'll start in a couple minutes.
Sitting here realizing, so normally I've right, I share my screen
Hmm.
and or not. That was interesting. There we go.
Oh, looks great.
And but I share my screen, and I've been leaving it on this when I should probably leave it on the title slide, right as people are rolling in.
Yep. Yep.
Yeah,
I liked Patrick's question about if we have Tiamat, then we should have what was the other the is there a water version?
Bahamut. I thought that was fantastic
Yes.
because yeah, who would win in a fight? My money's on Bahamut. As a Final Fantasy fan, it's Bahamut.
Trogdor.
Nick Hughes is right. Don't mess with Deburninator. Burninating all the peoples. And the thatched roof cottages. There are people on this call, man, right now who are like, what is Trogdor? Yep, and the Trogdor comes in the night. Okay, somebody's gonna need to put a link to Trogdor
I'm on it.
in the chat. Um, just in case somebody doesn't get where this joke is going. Oh, Wayne, you brought up Trogdor in your gardening talk yesterday. That's phenomenal.
He was an Easter egg. Oh,
Yeah, Trogdor comes in the night. I've really enjoyed these the casual presentation banter. I'm glad we still get a little bit of that.
oh, absolutely. Yeah. Well, we're whenever you want to jump in, I figure you don't need any introduction. So
All right, I will accept a lack of introduction. Um, we've just about wrapped up with SaltConf. Really excited to see some more folks in here. And like Dave just said, I suppose I don't need introduction, especially not anymore, uh, since I've given quite a few presentations at the SaltConf, which has been a lot of fun. Now, for those of you joining, looking in the chat, an earlier reference to a number of different dragons came up, and Trogdor was mentioned. So a bunch of people are laughing about good old Trogdor, the Burninator. But this presentation is not about Trogdor, the Burninator, but it is about Tiamat, a multi-headed dragon. And it's all about taming the dragon. One of the biggest problems with Python code distribution is pretty straightforward. It's getting that code into the hands of consumers. It is distribution. When we write Python code, one of the big benefits that we have is that because it's interpreted, it's very easy to execute, it's very easy to use, and it's ridiculously portable. But it's portable with the assumption that the interpreter's generally already going to be there. Many people have grappled with this distribution problem because in a lot of situations, you assume that Python's already going to be on the target system, so you end up saying, I'm targeting certain versions of Python. You assume that, or you bundle Python with your own distribution and ship it out, which can be really cumbersome. And there are tools to do that, but a lot of them are difficult to use. There are a number of different mechanisms that can be used to bundle just your Python code and all of its dependencies. And then you rely on the system that's out there. And so, again, what I'm driving at is that the Python community as a whole has struggled with the distribution problem forever. And so I would be exhibiting a significant amount of hubris if I came in here with waving a flag that said, I've simply solved the problem. There are still some problems that we haven't been able to quite solve with Tiamat and what I'm going to be presenting on today. But I certainly feel that we are in a really good position to come back and say that this is a really good way to distribute Python code. Okay. And so again, I'm really confident in that. And so as we start out, I want to talk a little bit about some of the more finite problems we run into with Python code distribution, and actually code distribution in general. Building and distributing software has long been a challenge. We go back in time, and there was a lot of difficulty because of the diversity of target platforms. And this concept has swung back and forth between different mechanisms of code distribution for years and years and years. We go back in time, and there was this target platform problem. And so you would compile a piece of software in, say, C, most likely. Definitely always has been one of, if not oftentimes, the world's most popular programming language and most widely used. Brilliant, wonderful, C. And so you say you write a piece of software in C and you compile that software. And when you compile that software, you can either have it dynamically linked or statically linked. If it's dynamically linked, then you might be sharing some of those libraries with other platforms. If it's statically linked, you include everything inside of your distributed binary, which makes it easier to put in the hands of other people, but the code's a little bigger. And if there's a problem with one of your dependencies, that normally would be shared, then it's your responsibility to update all your customers. And so you inherit a larger portion of the liabilities of the dependencies that you rely on. And we have waffled back and forth between these two distribution styles over time. Now, right now, hands down, the current winner in the distribution style debate is very clearly static distribution. A lot of the reason why static distribution is winning today is because the price of storage has plummeted. And this is why you can have on, say you've got an Android phone and you install an app, and the app does hardly anything, right? It's a real small little UI app that has some rudimentary API to a web interface. And you install that app, and it takes up 80 megabytes on your phone. That's a lot of space for some rinky-dink app. But because static delivery of these applications is so much less complicated and easier to manage from an overall distribution toolchain perspective, that static deliverable is what wins. Because what matters the most in software distribution, especially when we're delivering it to a consumer, is just getting it in the hands of the consumer. And our phones have plenty of storage now. Our computers have lots of storage. And we don't store most of our stuff on our computers anyway. So it's all in the cloud. And so what a consumer uses that storage for has changed. So what I'm driving at is that the world is leaning much more towards larger single distributables. Python wasn't made to do this. Not at all. And so the Python community has had this distribution problem for a long time. And so this is where Tiamat comes in. Now, a lot of people have tried to solve this problem in Python. And so, I mean, I shouldn't skirt around that. Tiamat, of course, is different, but it also directly inherits from a lot of the things that have been done in the past. But so let me start by just talking through what Tiamat makes and a few things that Tiamat does. Because Tiamat builds and delivers a static build of a Python application. And there are reasons why we went through the trouble of putting this thing together when there are other ways of doing this out there. And there are other ways of distributing Python code, and going through and building this whole system is, of course, a liability. But we've had a great deal of success with Tiamat. We've already worked out many, many, many issues to the point where it's very reliable, very easy to use, and the code that we distribute is very clean and in and of itself allows for a certain level of Pythonic dynamism, even after it's been distributed, which is really exciting. And so let's start by what Tiamat makes. Tiamat takes a Python code base and spits out an artifact, a deliverable artifact, plain and simple. We can either spit out a single binary artifact, so everything wrapped up in one single exe, or we can spit out what's called a one-dir or one directory binary collection. Both have benefits. For Tiamat to work, it bundles up a large collection of Python code, okay? Basically your application, and then it parses all of the dependencies that your application has, downloads and installs all of it into a virtual environment, or a PyVM, of course now, installs all of it into a virtual environment, and then it optimally installs additional things into said virtual environment, and then passes that virtual environment to a single binary builder. The default that we use is PyInstaller, and ensures that PyInstaller includes inside of all of its own internal paths everything that was in that virtual environment, which means that everything that you would normally do to set up and distribute your Python code using the built-in setup systems that are utilized by pip, just it all gets included into that Tiamat binary. And so what that means is that when we actually execute that Tiamat binary, many of those files need to be unraveled on the fly onto your system into an ephemeral directory. And so if you run the single binary and it's a really big software project, it can take a little while to start up. Initialization is slow. And the initialization of the Python interpreter is still arguably a little on the slow side, right? On a modern system, it can take somewhere between 80 to 200 milliseconds just to get Python going. And so that other option, the one directory option, gives you all of the artifacts or the artifact that is packed into a single binary, but what it looks like after it's unraveled dynamically into a single directory. And so that lowers your startup time considerably, because if you end up with a single binary that is 150 megs, it just takes a little while to unzip that thing. Even though, granted, on modern systems, it's still really quite fast. It still can be done in second and a half, which I don't think is anything that should be scoffed at, but definitely something that we should make sure that we have compensation for. And so that one directory option means that you don't have to run that unraveling step, and so it's just a little faster. But so again, those are the deliverables that Tiamat makes. In making those deliverables, Tiamat does a lot of things for you. And a lot of these things that Tiamat does are inspired by some of the modern static build systems that are out there. As we go back and we look at how Go builds artifacts and how Rust builds artifacts using cargo. Inside of Tiamat, we wanted to be able to say, let's try and make building and distributing Python code as easy as building and distributing Go code or Rust code, or again, a lot of these other systems that are a little newer than good old Python. And so we can ask that question of, why should we bother using Tiamat? The first, let's see, I would say the first dragon in the room is that one of the good reasons to use Tiamat is that it integrates with all the tools you already have. Chances are your Python project will work with Tiamat. If you're distributing an executable and not just a library, because if you're distributing a library, you don't even worry about this. Python library, you just toss it up on Python and you're done. But if you're distributing an application, chances are, again, you just don't need to worry about this. Not at all. It already is 99% of the way there. All you've got to do is add one little file that can be as small as a couple of lines of code, and you're good to go. So one of the big reasons to use Tiamat is really easy to extend your project to be able to use Tiamat. You don't need to add any dependencies to your Python projects. You don't need to do a whole lot of work or maintain a complicated tool chain. As long as your requirements.txt works and your setup.py or setup config works, Tiamat's going to be able to do the heavy lifting for you. Another reason to use Tiamat is that Tiamat is a wrapper. So Tiamat is built using POP, and as such, everything is ridiculously pluggable. And so when we come back and we take a look at the long, Python's been around for 30 years. Over that time, we're not the first people who've said, boy, that'd be great to make a single binary. But there are a lot of projects who have been grappling with single binaries for a very, 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 very long time. And so Tiamat is effectively a convenience wrapper around all of these different single binary build systems. Because oftentimes the single binary build systems can be very difficult to set up. You've got to work with a lot of different Python environments. You've got to, let's see, you end up having to compile a lot of custom stuff. So like in PyInstaller, for instance, is built primarily to build a binary based on an installed piece of software on a system. So Tiamat takes care of all of that difficult fluff around these projects. And Tiamat also works, I should mention, for Linux, Windows, Mac, Solaris, and AIX. And what that also boils down to is that we can build these binaries for any major platform. And I'm going to argue that that actually makes Python code. And Dave Murphy just informs me in the to not forget good old FreeBSD, of course, FreeBSD. And so Tiamat goes in and solves a lot of those build problems and annoyance problems that you get with these single binary builders. PyInstaller, for instance, is notorious for being fairly difficult to get going. If your Python code isn't all inside of an import path tree, then it's not going to ship all of the necessary code. The PyInstaller still has problems with setup tools. We fixed those. PyInstaller's configuration is kind of cryptic. I mean, the thing was written a while ago, and we make it so that you don't ever have to touch or think about that sort of cryptic setup. Tiamat is made so that you can build binaries directly out of a Git checkout, and so you build them off of your code. You don't have to install anything. Tiamat also has options to build external libraries and pack them into your application. So for instance, if you've got an application that relies on a third-party binary executable, we can build that into the Tiamat binary. If your application depends on a third-party C library, we can build that into your application. And those can be built at build time, so that you can have a complete build tool chain that's nice and smooth. And Tiamat can also make binaries that are portable across multiple Linux distributions. This is a particularly annoying thing, and this took us a while. This is a particularly annoying aspect of Python on Linux. Because unlike Windows, for instance, Windows presents a consistent ABI interface across multiple versions of Windows. So as much as I am a huge fan of Linux and I rag on Windows all the time, they certainly got that right. Whereas Linux's ABI interfaces are, let's just say they're not cross-compatible across distributions and versions. Tiamat gives you the capability of building single Python binaries that can be run on multiple systems. And generally you do that just by building against an older libc. That's an easy thing to do inside of an old CentOS container or virtual machine. Or it allows you to include extra glibc libraries inside of your own binary. And so I think we've got a lot of really good reasons to start thinking about using Tiamat. Next, I want to point out that Tiamat is really easy. The only thing that Tiamat really needs, is an entry point. Since we're building a single binary, that single binary needs to encapsulate the entry point into your code. This is challenging for all the Python projects that have multiple startup scripts. Salt's a good example here. The way that we got around this in Salt is that we created a single entry point for Salt, which could branch out into any of the startup scripts that Salt comes with. So you end up with a single binary of Salt, and you can start up a minion. You can run the basic Salt command, et cetera, all off of that single binary. And we also facilitate creating those binaries in such a way that you could disable components. So you can have a Salt single binary that's built with Tiamat that can't start a Salt master, for instance. So it's easy to do. All you've got to do is create what's called a run.py. And as the author of your own application, you would probably know how to initialize your program. But usually a run.py just looks like this. So here's the run.py for item. We just import item.scripts because we use item.scripts anyway as our setup tools entry point, right? And then we just initialize the entry point inside of this run.py. That's it. So I got to do. And assuming that your setup.py works, you're done. So again, that's literally the easiest, I would argue far and away, the easiest way or easiest system out there for putting together a single binary system for Python. With that said, I would love that, it's one of those things I keep beating around. Every now and then I sit down and I spend some cycles and try and figure out a good way to do it, to reliably figure out what your initialization path is, just from the setup.py. That's proven to be a little more complicated than I would have liked to cover the edge cases. So that's why we don't quite have that in there yet. But again, that's pretty darn straightforward. And it's pure Python, right? It's not like, and it's not even funny business Python. I mean, it's an import and a function call. So anybody who's able to build a Python project should be able to use Tiamat. And so let's talk a little bit about what building with Tiamat looks like. And so, again, it's very, very easy. And I'm actually going to hop over to a terminal. And do a little live demo. I'm actually going to start with destroying my last Tiamat build. So what we're doing right here is we're calling Tiamat build. And we're saying the name of the application that we're going to build is called Bond. Bond, this is just a prototype Python project that I'm working on. And I'm also going to look at it and say, look, I want to target a specific version of Python. Wayne, excellent job at that Goldfinger reference. We're going to target a specific version of Python. In this case, I'm targeting 3.7.10 because I just happen to know that I've already got that precompiled on my system. If we have Tiamat installed and we have pyenv installed, not to be confused with pyvenv, and we have pyenv installed, then Tiamat will call out to pyenv, and it will download a desired version of Python, and then build against it. So it makes it ridiculously easy to say, oh, I don't necessarily want to use the version of Python on this system to build my distributable. I want to use an older, newer, et cetera, et cetera, et cetera. And so again, in this case, I'm using pyenv to say I want to specifically use 3.7.10, and the name of my build is Bond. And just hit it and wait for a second. And I realized I did not run that verbose. Otherwise, you'd see massive streams of data flying by. But when it's done, and it'll only take a moment, we will have a single binary. What it's doing right now is creating a temporary directory, setting up a virtual environment, installing the code that is in the present directory, of course, using pip, and then going through and installing all of the dependencies that it's finding inside of the requirements. It's also installing a few additional components in the virtual environment, particularly PyInstaller. So you don't have to have PyInstaller installed to use Tiamat. It takes care of that tool chain on your behalf. And then it scans all of the files that are in that directory. It ensures that all of those files are going to be accounted for and properly linked inside of PyInstaller. Then it looks and finds all the files that are not going to be linked from PyInstaller, but are included in the build, and adds those as data files inside of paths relative to the type of files which they are. Which means that how PyInstaller works, for instance, there we're done. How PyInstaller works, for instance, is that it will begin importing code through Python and then include the entire import path. We're being a little less frugal with disk space, if I'm honest. I'm exchanging disk space for ease of use. We are including everything that's in there, and then we do go in and we clean up a bunch of things that obviously we don't need, particularly artifacts for things like setup tools and whatnot that are just not going to be needed inside of the application once it's built. But so now we have our single binary. Now this is, I said, a prototype, this is a pretty small piece of code I've got here on Bond, actually. 5 lines of code installed. Yeah, not a whole lot of stuff going on. And so I will own the fact that that's a big binary. That's a lot. But yeah, it's Python. The complete Python interpreter is in there. All of the necessary Python dependencies for this application are in there, as well as all of the Python core libraries and site libraries that are needed. And so, yeah, the binary is a little big, but the end result is that it is a binary. And so I can do this. And it runs just fine. And I can follow that up. I can actually, run my little prototype transpiler, run a little test I've got in here. And that worked. That's what I wanted to see. And again, it's all inside of this nice little 24 meg binary. So if I follow up here and say Tiamat-help, actually what I should do is wonder why this is slow. Did not pick up it didn't pick up the enter. Okay. If I say Tiamat-help, this is one of the things that I was mentioning before is wonder. Tiamat is, we got quite a few options that we can pass in here. And so, for instance, we can run it and pass to a specific directory. Tiamat, if you don't pass it to directory, is assuming it's running out that the root of your Python project is the directory that you're currently in. We can go through and we can explicitly exclude a list of files. We can create a Tiamat config for a project if we want to do things more complicated than just build it directly from what we have in the setup.py. That config is particularly useful if we want to do a few more features I'll talk about in a moment. And what was the one thing? Oh yeah, I want to do Wonder. And I will let that stew for a moment. Okay. So while we're building that Wonder system, so I can show you what that looks like. Let's see. Yeah, so we can go back, and the next thing I'll talk about really quick is the built-in build system. The built-in build system for Tiamat allows you to define independent steps to download, build, compile, validate, et cetera, et cetera, et cetera, any arbitrary third-party piece of code. That makes it really easy to say that Tiamat is able to encapsulate building any additional components that you need inside of your platform. A great example of this is, let's say that we want to use libsodium. Okay, I'm a big fan of libsodium. We don't use it anymore because, well, it's a long story. Oh, let's see, it's done. Excellent. Okay. So let me show this to everybody again. Oop. Keep that finger in that equals sign there. So inside of our dist directory, we've got the single binary that we built before, and then we have this run directory. This run directory is going to have everything that's in the single binary, but this is the single directory, and then it has a single binary in there named run. And that's how you start up your program. So if I do dist, my brain just, run. That's right. And same thing, right? We've got my little application here, and I can run my little test. It runs, okay? All right. As we look inside, we see that we've got this run binary here, which is just short of 5 megs. This includes everything that you need to initialize Python. So an actual Python binary doesn't exist wrapped in the larger binary. All that information is packed into run here. And then that goes through and has a bunch of these dependencies, right? Dynamic libraries that the Python instance that we built against has included. And then we also go through and we see that there are all of the Python dependencies. So the actual bond code for this little project that I've got is in here. But for instance, we've got some message pack. I'm writing a software project. So surprise, surprise, it uses pop. And a number of other things, okay? But so we can now take that single directory and distribute it, tar it up, zip it up, give it to an end consumer, have them unravel it, and you're off to the races. Okay. So that was a nice long-winded explanation of that slide. And there we go. My slides are taking a long time to load. It's always. I think I've actually done a pretty good job of padding for little hiccups, but now I've just got a little spinning wheel over here. Okay, that's adorable. Office 365 is basically now going at the speed of slow. Are the slides written in YAML? I wish. No, they're PowerPoint. I got it fixed. I'm good. We're back. Dave Christensen's hopping in. He's like, what can I do? Slides in YAML would be amazing. I do believe that there are some programs out there that can do that. A bunch of different markup kind of things out there. Okay. So, how do we solve big problems? There are big issues with making single binaries Python projects. Okay, and so this is the slide where I tell you these are the problems that we have not been able to solve. And there's actually one on here that I don't have listed. So, environment completeness. I've talked a little bit about that. We do ensure that you have a complete environment inside of the Tiamat binaries. So you're not going to be running your software and then something will be missing. That's a major issue with most of these single binary builders. Path issues. Really what we're looking at with path issues is that when we make single binaries, we need to make sure that all of the necessary Python paths are remapped into these sub-environments. This is something which gets tricky if you add additional files to these binaries. And you don't rely entirely on kind of the existing binary builders tight little tree or scope of the Python project. We take care of all that. That means that you can do local file lookups and relative file location and path lookups inside of a Tiamat built binary, even though guys like PyInstaller have some problems handling that. We fix those. We fix those external to PyInstaller. Tiamat makes sure that all of the temporary and ephemeral data that it unravels is done so in a secure location. It's not trying to execute code directly under temp. This is also a very common problem that we have with single binary builders. Another common problem that we have not solved is the sys.executable problem. Inside of Python, there's a variable. If you import the sys library and you go to sys.executable, it'll give you a path to the Python executable, which means that inside of a Tiamat binary, you cannot, sadly, directly invoke the raw Python interpreter from whence your code came. I would really like to get that fixed. We did have to go through Salt and clean up any instance of sys.executable. With that said, usage of sys.executable, I'm going to argue in Python, is 19 out of 20 times, that's bad code. There are certainly corner cases where I think that it's okay, but you do need to be careful with it. And so the other thing is, let's see, Robbie just mentioned in the chat that it's like PEX. Definitely very similar to PEX in a number of regards, outside of the fact that PEX does not bundle Python itself. Let's see. So the next is, can I force add local environment files? Yes, definitely. And yes, here is your medieval Trogdor reference, cycling back to earlier here. This parchment was found and sold to Yale University back in the 50s and has only recently been discredited as a modern fraud. But for a long time, many people thought that perhaps Trogdor did exist in medieval times. If somebody gets my reference to the Vinland map, extra points. So system libraries can be added into the binary. So this means that occasionally when we're doing a binary build, the binary build tries to only include expressly what it needs from your system paths. But we've run into a couple of situations where we have needed to add a few system libs into binaries. And so we added the ability inside of Tiamat to add a flag that says, yes, do not omit some of the Python system libraries. And again, you can also add in your libc libraries and some of those core Python dependencies that generally Tiamat still assumes is a dynamic link. That does, of course, make your binary a fair amount larger because you end up including libc, but it does make it more portable instead. So you've got that option in a Linux scenario. Do you want to build against an old libc and bring it forward, which works quite well? Or do you want to include libc? Generally speaking, for Salt and most of the projects we do here, we're building against an old libc. Libc's binary forward compatibility is really quite good. We don't run into real problems there. All right. What about C dependencies? So, of course, when you are running a Python project, you very often have dependencies that are written in C, because Python, like a good programming language, can call out to C libraries. And so if you want to add C dependencies, there is an option inside of the Tiamat config called build that creates an additional build environment, which you can use to download and compile additional shared libraries and get those embedded into the binary or into the directory. Your LD library path is taken care of so that the Python instance should be able to find those, and then you can use C types or whatever to include those completely external C dependencies. Outside of completely external C dependencies, these are, of course, absorbed inside of your standard setup.py. So if you've got a Python dependency that bundles in its own C dependencies, you don't need to go this far. That's already handled by your dependent library, which is also a reason why sometimes it's easier to say, yeah, just depend on statically inclusive libraries that are going to pull in their C deps as well. But if you've got those that don't work that way, we do have an answer for you. Next, can you target specific Python versions? I talked a little bit about that earlier. Yes, you definitely can target specific Python versions. In my demonstration before, we targeted 3.7.10. You can target any Python version which is provided by pyenv. Pyenv is not installed by default as a dependency to Tiamat, though. So you do have to install pyenv in addition to Tiamat to take advantage of this feature. But all you've got to do is say pyenv and then the version that you want. Inside of the CLI help on the pyenv options for Tiamat, it gives you a command that you can run that can give you a list of all of the available versions as well directly from pyenv. So that becomes a lot easier. Now, with that said, we only test Tiamat against CPython. Pyenv does allow you to install things like PyPy and alternative versions of Python like IronPython and JPython. We aren't testing against JPython or IronPython or PyPy. Everything is against CPython. So don't get too excited when you see those opportunities, because they're not there. Sorry about that. But frankly, I think it would be great if we could build this to also cover PyPy. I think the PyPy is absolutely brilliant. So let's see what else do we have here. That's what I thought. So we've got a few minutes left. I'm trying to think if there's anything in here that I have missed. This is what I ask. Does anyone have any questions, comments, arguments, or rebuttals?
Emotional outbursts. Yeah. So in the Q&A tab, there's a few questions in there, and if you want to sort by popular, then we can kind of go by upvoted comment.
I must admit, I've gotten so darn. I should remember that it's there. Does Tiamat require the host and target platforms to be the same? Yes. We do not have cross-compiling built in yet. Boy, that would be great. Cross-compiling would be really, really complicated for this setup, though, if I'm perfectly frank. So yes, the host and target platforms need to be the same. What about Python package management? Dependency solving, locking versions, updating, verifying checksums of all things about to be installed. We use pip directly. And so when it comes to dependencies and locking versions and everything like that, as long as it is set inside of your requirements.txt, you're good. Okay. And so just make sure that you've got your requirements.txt there. If you want to use an alternative requirements.txt for your distributable build, you can have an alternative requirements.txt and just reference that when you call Tiamat. So yeah, you can give it an alternative requirements file. When to expect a single binary release for Salt 3004? That I'm going to ask, I just forgot David Murphy's name for a second there. I'm sorry. I'm going to ask David Murphy if you can answer that in chat, please. I appreciate that. If you have an answer. You're a little closer to that. You're the one in the pipeline there. Is Tiamat considering planning to support PyProject.toml? Yeah. Yes, we're definitely planning on supporting that. There are, I think there's a couple of set.py liabilities we still have in there that we need to clean up. But in a nutshell, we should be able to do it, do anything that pip can do, and that's basically the line that we're drawing. Because for your built-in application, we are effectively just pip installing into the virtual env from that local directory. So I wouldn't be surprised if that works right now, to be honest. But I'm hesitant to make a promise without double checking. I don't remember off the top of my head where we are there. But by all means, yes, we would like to do that. How do Salt extensions work with single binary releases? Salt itself, the Tiamat build of Salt itself solves one other problem. But we want to upstream this into Tiamat. It's a little complicated. Salt can have extensions installed, oftentimes via things like pip. And so inside of the Salt single binary, you can actually run pip and run extension installers. And those install into an extension directory that is maintained on your system. And then the single binary will add that extension directory into its own Python resolution paths. And so that can be used to install not only additional Python dependencies, but also extensions. Salt single binary release production ready. When will I shed the beta tag? We're working very hard on this. There are a couple of gnarly, really deep little issues that we've got left. But in a nutshell, what we're looking at here is very soon. We're really hoping that the next release we can have it done. But again, I'm not going to make a hard promise there. But that's certainly an aspiration. Let's see. Can only package pure Python code write? Hence the move away from some Python libs that use C behind the scenes, I imagine. No, we can package C code. A lot of the reason why we move away from libraries that use C behind the scenes is actually because you end up with larger platform dependencies, and it lowers the portability of the overall code base. And this is also particularly true when we're relying on C libraries or on package managers, for instance. But yes, Tiamat can bundle C libraries, C dependencies. Heck, you could shove a jar file in there if you wanted to. I mean, if you were really, really a masochist. When telling Tiamat to include deps when building package, would such package be suitable to run in an otherwise empty container? Okay, let me read that again. When telling Tiamat to include deps when package building, would such package be suitable to run in an otherwise empty container? Yes. Yeah, the Tiamat artifact should include all dependencies. Now, you might want to actually test your binary inside of a clean container, because the Python that's installed in there will potentially, I mean, it'll still follow basic Python path rules. And so it could pick up at the bottom of the Python path list some installed dependencies if you've failed to include them in your binary. So just because it runs on your build system, it doesn't necessarily mean that it will run in that isolated environment, which is not too dissimilar from, say, building something with C. So just want to make sure that that's clear. Make sure that you do have all of your dependencies listed. Otherwise, your binary may still have problems. Let's see. And Robbie says, I missed the beginning portion of the session. Does Tiamat provide an offline mode? That is to say, no external code is downloaded during build process. It does. And I'm trying to remember how I built that, because I did that. But yes, Tiamat offers an offline mode. If I recall, you are able to create a separate package of all of the dependency source files. And if you include that package in your, let me just try and see if I can remember what the flag is. Answer that, as I am nigh running out of time. There we go. Sourceter. So you can run Tiamat build --sourceter. And then the doc here says, instead of reading in a requirements.txt file, install all of the Python package sources and or wheels found in a specific directory. And so, yeah, you can do it in an offline mode that will not go to your requirements.txt file, and it'll just install everything you've got in a directory. Which allows you to have your dependency management be out of band. Okay, Dave, thanks for pointing out that there's a Q&A. I should really remember that now that I don't have any presentations left. You would think I would have learned this by now, and since I've been talking nonstop for 2 days.
I would use it once a year, you know.
Okay, any other questions, comments, arguments, or rebuttals? Sounds good. The demo jam's next, right?
Yeah.
Sweet.
Everyone, thanks for attending this, and I think we'll hop over to the demo jam. Yep. Thanks, Tom.
Definitely go to the demo jam. It's freaking awesome. Adios, everyone.
Bye.